These properties of logs are a review of what we saw yesterday. Yesterday we took a single log and expanded it to multiple logs. Today we're going to do the opposite. We're going to take multiple logs and condense them to a single log using these same properties. So our essential question today is, how do we use properties to condense? And then we'll use properties to evaluate logs as well. When you're condensing logs, the first thing you want to look for is multiplication, and you'll turn that multiplication into a power on what you're taking the log of. Both of our log expressions have multiplication, so we'll turn both of those into a power first. So we've got log of x to the 1/2 plus log of x plus 1 cubed. Then we take a look at any addition or subtraction. Addition means we condense to a single log and we multiply what we're taking the log of. So we will get log of x to the 1/2 times x plus 1 cubed. Off to the right, I'm going to show you a common mistake that I see students make, and I want to talk about how not to make that mistake. So what I see a lot of students do when they're condensing is simply change it to multiplication without canceling one of the logs. So what they're essentially saying is adding equals multiplying, which we all know is not true with regular numbers, but when we start throwing logs and variables in there, sometimes we forget our basic math rules. So in order to change addition to multiplication, something else has to change too. And that's something else that changes is we cancel one of the logs. So be careful for that common error. Taking a look at example B, we have another multiplication, so we're going to turn that to a power. So we have natural log of the quantity x plus 2 squared. Our second natural log does not have multiplication, so we're going to leave that alone for now. And next we condense the subtraction. So same thing. When you change the subtraction to division, you need to change something else too, otherwise it's no longer equal. So the something else that we change is we cancel that second natural log, and what we're taking the log of becomes the denominator. For some of you, it may be helpful to put brackets around it so that you understand the natural log is being taken of everything. Our last example, this time order of operations tells us to condense what's in the grouping symbols before we do that multiplication out front. So I'm going to leave the 1/3 for now, and I'm going to condense them to a single log, so I'm going to drop the brackets. Log base 2 of x times x minus 8. Another option is to distribute the x, but if you do, you cannot drop the parentheses. So let me show you what that notation looks like if you choose to do that. The reason you cannot drop the parentheses is, and I'm going to drop them right here just to explain what this notation is. If you drop the parentheses, order of operations, the log acts like a grouping symbol. You will take the log of x squared before you subtract the 8x, and that's not what we want. We want to take the x squared minus 8x before we take the log of that result. For the purposes of the power, I think this is actually the easier route to go, because next when we make that 1/3 a power, we've already got it on everything. Whereas that first one, you would have to remember to distribute the 1/3 to the x as well as the 8 minus x. So in this case, we can get that 1/3 distributed all at once.